Welcome to Maths with EJD. In this video, I'll be talking about applications of Fourier series to image processing. So in image processing, Fourier series and related transforms like the discrete cosine transform, discrete cosine transform, that is DCT, are used to analyze and manipulate the frequency, the frequency components of images. JPEG, JPEG is a very popular picture image format. So JPEG compression is a prime example, of this technique. Hmm. So let's talk about JPEG compression and DCT. That's discrete cosine transform. JPEG compression and discrete cosine transform. Okay, so JPEG compression works by transforming an image into the frequency domain using the DCT. Okay, so the 2D, the two-dimensional DCT for an image, I of x comma y is given by so let's see that's DCT of I equals summation from m equals 0 to m minus 1. It's discrete this time around. Summation n equals 0 to n minus 1 of a m comma n cos, so cos pi into 2x plus 1m all over 2 big M. Okay, then cos pi again into, it's two-dimensional. That's 2y1 into small n all over big N. Okay, so that is what that looks like. So this is the formula. So for all this JPEG, whatever you're seeing, so this is the maths behind it. Though, I mean, most of the times the maths, you can care less about the maths, right? But this is what is making that picture transformation you see possible. All right. Um, okay, yeah, the 2D DCT for an image Ix of is given by this formula that we have right here. Discrete cosine transform. Okay, so where a m comma n are the DCT coefficients. The whole Fourier thing is all about computing the coefficients to know the weight, the contribution of each signal, of each wave in the whole process, where AMN are the DCT coefficients, and then we have big M and big N are the image dimensions, okay, and X comma Y are the pixel positions. They're the pixel positions. Like I said, I have a playlist on scientific computation with Python. So they'll be talking about fast Fourier transform. So we are going to see more of this image processing I've been talking about in that playlist. So watch out for that. There are some videos there already. You can already begin to look through, and then I'll come to talk about fast Fourier transform and all of that later. So let's look at the compression process. What does the compression process look like? If you want to compress a picture, so the compression process. Okay, let me make it bigger. The compression process. So first you talk about the the first part is the transform. So the transform. So you have the image. The image is divided into blocks, e.g., you can have something like 8 by 8 pixels, okay, and transformed using the discrete cosine transform. Okay, I guess this is too thick. Let me go to what I was using before. Then number two, you have the quantization. After the transformation, you have the quantization. So for the quantization part of things, is have that the high frequency components are quantized. Quantization simply talks about reduction, right? They are quantized or reduced, and the resulting coefficients, the resulting coefficients are compressed. Okay. Then, transform quantization. Then, three, you have the encoding. The encoding. Number three, you have the encoding. Transform, quantize, and encode. So for the encoding, right, the quantized coefficients are encoded into a more compact format. Okay. So finally, right, by discarding high frequency components, so JPEG compression achieves significant data reduction while maintaining visual quality. All right, so that's that about this part, which is application of Fourier series to image processing. So you can see Fourier series has that kind of uh real application in image processing. In the next video, I'll be talking about spectral analysis. You also do not want to miss that. So some of the technologies we enjoy actually are backed up by some of these very interesting mathematics. So subscribe to this channel. Subscribe, hit the subscribe button, hit the notification bell also, so you can always get alerted each time a new video is released. And don't forget to comment. Let me know how helpful these videos are. Let me know if you want to teach a topic or solve a problem. Also, like and share so that more people can have access to this great content. So, like, come your way again. Have a nice time. Bye.